introduction. I'll let John tell you more about his background, but just briefly got to know John over the few years I've been in ham radio. I keep running into him at Buffalo, March Madness, frequently. The table he's at, which is with the Northern Lights group, is next to our table, so I've got a chance to talk to him a couple times there, but very fascinating. I've heard him speak a couple times as well, and I think he'll bring an interesting approach to the technical side of ham radio for us when it deals with VHF, UHF, microwave stuff. So ask questions, ask away. You know, as I was telling him, the stuff that he does, you can't go to Radio City and just buy the stuff off the shelf and do it. I mean, you gotta know what you're doing. So ask a lot of questions, and thanks, John.
Thanks, Chuck. Thanks for the radio club here inviting me to speak in front of you. I really appreciate it. This is the second presentation I've done in 2 days, different subject. So I've already used up my 8,000 words that I'm allowed to use per week, so cut me a little leeway if my voice gets a little scratchy or something. As Chuck said, you know, this is going to be very informal. This presentation is, you know, I've done several presentations like this through the years. This one is unique from the standpoint that we're going to talk about, you know, the world above 50 megahertz, and there, you know, what a great hobby. There's so many things to do. There's so many aspects of the world above 50 megahertz, and we're not going to spend any particular length of time on any one thing, you know, like EME or 6 meters or anything. But we're going to do like a quick hop through all these different topics, and I hope in doing so that, you know, we'll spark a degree of interest in all you guys on one thing or another. You know, that the fact that you guys are, you know, more into the technical side of the hobby and into building stuff, that fits so much into the world above 50 megahertz, as well as operating and some other things that we're going to talk about. So, as Chuck said, this is going to be informal, so if you have questions, you know, just pipe in, just jump in. If you have some comments, jump in. If it gets long, we'll kind of cut it off and move ahead and stuff and take questions at the end.
Until 6.
We're here to 6, you don't kick us out. Might get hungry, don't know. But, let's just jump in here. First of all, let me tell you a little bit about myself. I've been an amateur radio operator since 1970, and my Elmer was a HF contester, and so I got into ham radio through contesting and through HF operations. So roots I still have. I have a home station. I also like to go roving and do operation on the road, mobile, both HF and VHF, but my home station is good on 160 meters through 3.4 gigahertz. I have 5 and 10 gigahertz capability, but I don't have it up on the tower because I have big maple trees all around me. I use those spans when I'm out roving. I still do a lot of HF contesting and a lot of DXing. I think I have confirmed around 230 countries, roughly. I have some more worked, but I don't have cards from. I don't chase that part of it a lot. I just enjoy it. It's a lot of fun. And when I was in college or so, I started getting interested in the world above 50 megahertz, and since that time, kind of have, you know, gotten more into that area. And like I said, I operate weak signal, VHF, UHF, microwave, and hope to share that a little bit with you as we move forward here. So this is one of my favorite pictures. Can we kill these lights? Do you think is there a chance? Will that help any? Can I do it?
Yeah, it's right back on the corner there.
Okay. Is that better?
Yeah.
Okay.
Yeah.
Okay. This is one of my favorite pictures just because it brings back fond memories, and I think it's a pretty picture. This is I was out roving for the June VHF contest, and this is out in EN24 out west of the cities, and I had set up on this little ridge there, and it was June, and we had a lot of rain, so it was green, and, you know, you get the grass going there, and it was just, the wind was coming in the window. It just brings back fond memories. That's a 5.7 gigahertz commercial dish with a transverter on top. So the transverter takes 5.7 gigahertz in and converts it to 2 meters, and then there's a coax coming down here that will connect to a 2 meter rig, and that's how you get on 5.7. The transverter there is a down-east transverter. It runs about 2 watts. That particular dish, really a nice commercial dish. I like it because it's cheap. It was only like $50. It comes with a feed on it, with a little end connector on the back, so you get the whole dish, the mount, the feed with the end connector, $50. I can't make it for that cheap. Plus, I just plug my coax and it's ready to go. I don't have to dink around with it. And that provides about 27 dB a gain on 5.7. So, just an example of one thing that is fun to do. So, when Chuck asked me about making a presentation, I jumped on it. Because, you know, first of all, I like to spread the gospel about amateur radio, but I'm talking to the choir here. You guys know how much fun this stuff is. So I asked Chuck, what kind of things might you guys want to hear about? And so he queried you guys and got some questions back. So we're going to hopefully address these questions as we go forward. What can be done? We're going to do a quick fly-through on all the bands. What are the technical hurdles? What about moon bounds? What's it take to get started? Can I build equipment? What's out there and what's being done locally? We're going to touch on all those, and then at the very end, we're going to come back and revisit these and see if we have any other additional questions around those. So the pictures down below, just to kind of whet your interest and get the excitement going, if this gets you excited, it does me, is a contact that I made from my driveway. So on the left-hand side, that's a picture of my dish for 10 gigahertz, 368 megahertz. And we'll see a couple more examples of that as we go forward. And I'm aiming kind of above the trees here, so this is looking to the north. And I'm aiming just above these trees here, kind of up at about a 10, 15 degree angle roughly. And I had made a contact with Bill, K0AWU, who is up in Grand Rapids, at a distance of about 155 miles. And this is a picture that he took. He uses a soft rock, he uses a Rocky on his receive side, and this is my signal that he's seeing right here. This little blip on the thing. So that was a 155-mile contact on 10 gigs made from my driveway. Now we did this on rain scatter, okay, and we're going to talk about rain scatter in a little bit. And so there was a big rain scatter, a big thunderstorm between us, and we were bouncing our 10 gig signals, just like radar off those. And we'll talk about that a little bit in a while. From my home, with all these trees around me, I've worked 7 different grids, and we'll talk about grids briefly, on 10 gigahertz. Which is kind of cool. So we're going to do a fly-through of all the various bands real quick. How many people operate 6 meters? 6 meter sideband, say? Yeah, it's a great band. It's a great place and a way to get on and start playing around with VHF stuff. Just about all the radios nowadays that you buy will have a 50 button. I always encourage people, and when it's got that 50 on it, you push that. That's where you want to be. That's the 6 meter band. And most of the radios nowadays, they're like 100 watts or even a 50 watt, like the little mobiles, like the FT100s and the 747s and all this kind of stuff. They're 50, 100 watts on 6 meters. Bingo, bango, you're on 6 and you're doing VHF. How fun is that? For those who aren't familiar with 6, that the primary frequencies of interest are 50.125. That's kind of the calling frequency, if you will. The CW band is 50.1 and down, in CW activity. Excuse me, typically takes place right on 50.1 and down. Over the last number of years, CW activity on 6 meters has really increased. Back in the day, it was extremely rare to hear a CW signal. It was usually only DX stations. But nowadays, you get a nice opening, and there's as many people on CW as there are on sideband, which is a lot of fun if you enjoy CW. Otherwise, sideband is usually 50.125 and up as the band opens. It's a lot like HF, it's a lot like 10 meters, so if you know 10 meters, you pretty much know 6 meters. We use horizontal polarization, so you want to stick with that. LMR 400 coax works very well. 100 feet of that only has a dB of loss, so good RG8 or an LMR 400 is fine to use, works just great. Power is pretty much as HF. A lot of people now are running higher power. A lot of the the commercial Icon amplifiers and stuff you'll see have 6 meters built into it. But 100 watts will work the world. The propagation mode. 6 meters is really interesting if you're into propagation because it's the crossroads really between HF and VHF. And at any particular time through the years and years, you'll probably come across one of these modes that are quite fascinating. Of course, F2, right now where we are in the solar cycle, we're not going to be seeing any F2 or very, 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 very rare F2. Just because the solar cycle, the solar flux isn't high enough. But when we have a good solar cycle, there's a period in there of several years during the peak of the solar cycle where there's F2 propagation. You can work the world just like you do on 10 meters with F2. Sporadic E is the bread and butter. There's 2 sporadic E seasons, generally speaking. The summer months, which is the big one, and right now there's a little peak again around this time of year. Sporadic E, you can work out 1,000 miles. Signals are usually generally very loud. Again, kind of a bread and butter mode of 6 meters. It's one of the reasons why the June, ARRL June and CQ Worldwide VHF contests are in that June and July time frame is to take advantage of sporadic E season. Aurora is a lot of fun. You can bounce signals off the Aurora Borealis, and those signals will sound kind of raspy because the Aurora gives you a little bit of distortion, a little Doppler, and on sideband they'll sound like a T5 or T6 note. On CW they're kind of raspy. A lot of fun. Meteors is also another bread and butter mode. So a lot of guys do meteor scatter on 6 meters. It's probably one of the best bands to start doing meteor scatter. The distance you can work on meteor scatter is about the same as it is on sporadic E because they're about the same height in terms of where the reflections occur. If you become proficient at doing meteor scatter on 6, you can work, every morning you can work people on 6 meters meteor scatter. And there's websites that help set up schedules as well as random capability to make random cues on meteor scatter. Tropospheric, that's where the change in the nature of the atmosphere from ground going up is such that it will refract radio signals, bend them back down. Inversions will often cause, we call it tropo in the VHF world, tropospheric scatter. And you do get tropo on 6. It's usually a little bit better on the higher bands. We'll talk about that here in a second. And then, of course, EME. EME on 6 meters is a little bit more difficult. It takes bigger antennas, a little more power. Some people do it, but EME is typically occurring on the higher bands. So that's 6. Moving up the bands, 2 meters is the other big band for VHF operations. 144 megahertz. The 144.2 is the calling frequency, so that's usually where most people hang out. Again, horizontal polarization. Most people who are on 2 meters doing weak signal VHF usually have antennas that are in the area of like 12 to 30 foot booms. So sometimes people will stack them to get a little bit more gain. I started out doing VHF stuff on 2 meters using 15-foot boom and 80 watts, and I was working all sorts of stuff. So that gives you an idea. LMR 400 is still good at this frequency. 100 feet of LMR only has 1.5 dB of loss, which isn't bad. If you can improve the feed line, that's great, but there's nothing wrong with that. It's a great way to get on. It's a low-cost way to get on. LMR is good stuff, LMR 400. Power, people are typically running, several tens of watts, maybe 100 watts. The bricks that are out there, the Mirage bricks, will get you up into the 100, 150 watt class. And there are solid-state amplifiers. We're starting to see more and more of the solid-state amps that are actually fairly low-cost, either partial kits or full kits, that will give you into the hundreds of watts or towards a kilowatt range on all the VHF bands. So that area, those amplifiers, used to be the domain of 2 amplifiers. They were seeing a shift into the solid state, particularly in the VHF area, and quite a bit lower in cost and very durable, very good. Propagation modes, again, we have sporadic E, which is rare now on 2 meters. Usually you only get sporadic E on 2 meters if it's really strong on 6 meters. It's also very rare. It's also very exciting. it's I've worked maybe 2 or 3 times this summer at the most 2 meter sporadic E opening. But when you hear it, it's really exciting. Aurora, again, kind of a big mode on 2 meters. When we have Aurora, meteor scatters is very popular. We talked about meteor scatter on 6 meters. Tropo is kind of a bread and butter mode for 2 meters. For 2 meters. As you get temperature inversions, as you get changes in the atmosphere from ground up, and you get those types of conditions that cause radio waves to bend back towards Earth rather than going straight out, as you go higher in frequency, that phenomenon is enhanced. Okay, so that's why 2 meters is better than 6, and sometimes why 432 is better than 2. Because for a given condition, usually the higher the frequency, the better the tropospheric condition. And of course, EME is very big on 2 meters. A lot of people are doing Earth, Moon, Earth, EME, on 2 meters. And we'll talk a little bit about that in a second. So that's 2 meters. A lot of people have 2 meter capability on their radios too. That's the 144 button. The other group of bands I wanted to talk about was UHF, which is basically 300 megs and up. If you want to include 222 and up, that's fine too. It includes for amateur bands 222, 432, the 902, 1296, 2304, 3456, 5760, 10368. So these are 24 something. So there's a number of bands as you're going up the spectrum that are amateur radio bands. Typically for antennas, people are using Yagis on 222 and 432. And when you move into the little higher frequency range, like 902, 12, 96, they tend to go to a loop Yagi, which are essentially just quads. So there's a picture of a loop Yagi in the bottom right. Those are actually full wave loops. They call them loop Yagis on UHF, and HF we call them quads. And one of the reasons that they're a little bit better, so quote unquote, on the high frequencies is they are much more tolerant of tolerance issues. So a Yagi, as you go from 2 meters down to 222, down to 432, now you're at 902, little changes in that length are going to have some significant effect on the antenna performance. And so the loops are a little bit more tolerant, and they work very well. They're very easy to build, whether you want to do as a home brew or a kit. They're pretty tolerant and they work very well. You start to get into the higher bands, like 2304 and up, people start to use dishes, parabolic dishes, rather than any kind of like parasitic antenna like a loop Yagi or other kinds of antennas like that. LMR 400 still works pretty good on 432, but now you're starting to see the increased loss, so don't hesitate to use it. If that's what you got, it still will work pretty good. If you can improve the feed line to like Andrews, 7/8, you can see you can pick up quite a bit of help. And what's really nice when you go to a better feed line is it helps not only in your transmit signal, but also on what you can hear. And so remember what we're talking about here are weak signals, okay? Not FM. We're talking weak signal stuff. So picking up a couple dB on weak signals is often pretty huge. So by any means, if you can go the route and improve feed line, do it. And if you can't, just get on and have fun. Power, again, it's kind of in that 100-watt range is typical for 222. By the time you get up into the microwaves, you're talking, a couple watts or maybe a couple tens of watts is kind of typical power people are running. Propagation modes, sporadic E is basically gone. It does occur on 222. It's very, very rare. I've had a one-way cue on 222 sporadic E once. I heard him, they didn't hear me. It was really cool. Aurora, again, rare, but it does happen. Meteor scatter, again, rare. People do meteor on 222 and 432. It's becoming much more of a challenge and much more rare. Tropo is a big mode on these bands. So that's why the ARRL's UHF contest is in August, because it's those later months in the summer. Think of summer, you think of July, August, September, the dog days of summer, the high pressure system, the weather systems slow down. You don't get the storm front sweeping through, the dog days of summer. You get the high pressure systems with warm cores that settle in. It's hot and humid, no clouds, or in the evening you see the clouds and the clouds are dissipating. That's because the air is sinking. And that's what sets up these inversions that helps propagate those signals. This is a chart, I think it's out of the ARRL handbook. People always ask me, how far can you work? And take this with a grain of salt. But this will give you an idea. So it's miles along the bottom, and it's the path loss along the top. So what this is showing is that the farther you try to work, the higher your path loss. So path loss is how many dBs of loss does it take to go from point A to point B. And the further they're apart, the higher that path loss. And you have to overcome that path loss in order to hear each other. And you can overcome that path loss either by having bigger antennas or more power or better receive or all the above. So what you see, though, is interesting is that there's this kind of knee that happens right here. So you get this kind of real high loss going on. And when you get out about 100 miles, the losses start to slow down. And then once you get further out, they start to accelerate a little bit again. So you can see, a little bit of improvement gets you, twice the distance. And, typically on any given day on 2 meters or 222, there's a difference between winter and summer in terms of propagations. But you can work out, 150 to 250 miles, maybe 300 miles. Depends upon what the station on the other end is running. So, if they're running 10 watts into a dipole, it's going to be a little bit more of a challenge. If they're running 400 watts into a pair of stacked antennas, it's going to be a little bit better. Okay? But, you can work several hundred miles, no problem, on any given day. And what's really exciting is when you get some aurora, or you get some tropospheric scatter enhancement, or you have some meteor scatter work you're doing, you can work much, much further. So microwaves, finally, is the last band we're going to talk to before we switch gears a little bit. Above 3 gigahertz, so there's the 3.4, 5.7, 10, 24 bands. And loop Yagis generally end at 3.4. The loops on a 3.4 Yagi, sorry, I was going to bring mine, I forgot. Their loops are about that big. So, they're starting to get pretty small. And so, you know, usually when you start getting these upper bands, you're talking about other kinds of antennas. You're talking about horns or dishes. That bottom picture there, that's a horn antenna. I think you've all seen those, what a horn antenna is. They are what they just sound like. And the particular gain for any particular frequency for a horn is pretty much determined by its aperture and size. So you can make a big horn, you know, for any given band that will have more gain than a small horn will have, for example. And there's all sorts of information about horns and how they work and how you can construct one and what kind of gain you can expect out of it out there on the internet and in various books. They're fairly easy to make because they're just kind of sheet metal that you can cut out and then bend it and solder the end together. So they're kind of a fun antenna for building. Power usually on these bands are measured in several watts. You know, sometimes if you're running 5 or 10 watts on the microwave bands, your QRO, you're running fairly high power. And we're going to talk about tropo a little bit, and then of course the EME, there's going on in these bands as well. And then rain scatter, we're going to talk about a little bit more too. This is an example I wanted to show you of during the ARRL 10 gigahertz contest of a contact that was made between Barry, VE4MA up in Winnipeg, and N4PZ down in Illinois. It was a 650-mile contact that was made on tropo on 10 gigahertz. So I have a whole other presentation if we want to do that sometime on tropo, and particularly this contact that shows kind of the weather that was occurring at this time and how that weather caused this path to open up. But that's a pretty good contact. They were pretty excited about that. So here's I had to spend a lot of time doing that. Oh. So this is an example of rain scatter. So, you know, all of us look at the National Weather Service radar from time to time, particularly when there's bad weather out and about and you can see the thunderstorms and stuff. Well, you know, we're doing the same thing here with rain scatters the radar is doing. The radar sends out a signal and it will reflect off the thunderstorm if it's in sight and come back, and they do all sorts of algorithmic work on it, and then you see it on the radar screen. The point being is that if the radar can see it, we can see it. So what we're showing here is that you can work up to about 600 miles distance if both stations can see the top of the thunderstorm. And what actually happens is that when we're working rain scatter like this is that it isn't so much rain as it is hail. Hail is a tremendously good reflector. And when you get up these high elevations, that's where the hail is at. You know, sometimes it melts as it comes down, but it's really hail for the most part that we're scattering off of, and it's at high elevation. So we actually get kind of excited. You know, I know a lot of people don't when we start seeing those 30 and 40,000 foot tops on thunderstorms. You know, we go, baby, go. You know? We just don't want to be underneath them. So we have there's a couple things that we do here.
Question.
Yep.
Now, do you aim for that?
Yes. I'm going to show you that here. Yep.
Okay.
So we have two things. First of all, the communication side. So we have an email reflector that those of us who are active on 10 gigahertz in the upper Midwest use, and we can talk to each other. And we have it set up so it just sends short text messages, and we'll say, looks like a thunderstorm up around Leech Lake. Barry, are you on? And Barry will see that email and he says, yep, I'm on, you know, meet you on so-and-so in 30 minutes or whatever. So it's a way to coordinate, and then we know that they're on and being active. So we use that for coordination. The other thing I wanted to mention is this is a snapshot of a program that was designed by Andy, K0SM. It's called Rain Scatter. If you do Google and look for Rain Scatter, you can download this program. And what it does is it uses the National Weather Service data on thunderstorms. So, the National Weather Service puts out a stream of data that relates to what azimuth a thunderstorm is at and how tall it is. And he uses that information from all the various, you can go in, you can select which National Weather Service radar stations you want to pull together. And in this particular example, we're looking at the Minneapolis radar. And this program shows that there's a path that's open between Mike down in the bottom left corner, KM0T. He's down in Sioux Falls, Sioux Center, Iowa, northwest corner of Iowa. And Eddie, VE3KRP up in Thunder Bay. And that big blotch, as you all know with radar and stuff, is the thunderstorm. And so the thunderstorm is kind of mid-path, but you can see, so that EN13 Victor Charlie, that's Mike's grid, that's where he's at. And EN58GK is where Eddie is at. And then the program will tell you the bearing for each station. So Mike aimed 30 degrees and Eddie aimed 230 degrees, shown on the dotted lines to that thunderstorm, and that's how they got their bearing.
But do you change the?
Generally speaking, you're on the horizon, unless you're very close to the thunderstorm.
Okay.
Yeah, they're generally, you know, a degree or two at the most.
Right over the treetop.
That's right. And so, for instance, like the dishes that we typically use on this band, you know, they provide about 30 dB a gain, and so the beam is about 2 or 3 degrees wide in both azimuth and elevation. And so, you know, 2 or 3 degrees off the horizon is usually, you know, where you want to be anyway when you're working these long paths. So generally not very much on elevation unless you're close, like in the treetops when I was doing that one from home. So this is really a fun thing to do, you know, and this is a great program that Andy K0SM has put together, and we use this a lot.
What do you use, voice or CW?
Typically, it starts out on CW, depending, so when you have the thunderstorm, it kind of depends where the thunderstorm is in its movement, because you'll get Doppler shift and possibly some distortion from all the different reflections that you get. Often what will happen is that the signals are so good that you can go to sideband. So they'll start out beaconing and trying to get each other on CW, and then sometimes they'll switch to sideband. And quite often you can then go to FM as well, because these signals are really strong. These are not, for the most part, these are not weak signals. These are pretty good signals, and they're often, it's either there or it's not. It's kind of like the thunderstorm, you can see it or you can't. And when you switch over to FM, it's usually full quieting. So we use a mix of modes. There's actually some guys who have been playing around in the last couple of years with digital modes. We're going to talk about that here in a second, but using digital modes on 10 gigahertz as well. Building and construction. So antennas, you know, VHF, UHF is a great place to play with antennas. You know, 6 meters is probably, I think it's the premier band for playing with antennas, because it's small enough where you can, you know, it's, what's a dipole, 19 feet, is that right? So, you know, it's not huge, but it's not critical either. So, you know, it's kind of a nice size. It's kind of like the porch, not too hot, not too cold. You're not too critical on dimensions. You can build a lot of really fun antennas, wire antennas, Yagi antennas, all sorts of fun things, quads, Yagis. There's a guy, Ken Britton, WA5VJB, who has designed what he calls cheap Yagis. And if you Google that call or Google cheap Yagis, you'll come up with that. And he has a whole set of designs. The good thing about it, or the interesting thing about it, is that his feed is designed around a J-pole. And so it's kind of a J-pole feed. Direct connect to coax. You solder the coax right onto the element. And they work, if you build it per the specs and stuff, you get exactly what it was supposed to be. They work very well. Easy to build. You can put together a 432 cheap Yagi for $5 and have a pretty effective antenna on the microwave bands. Horn antennas we talked about. Recycled direct TV antennas. We'll see a couple of those coming up, but that's what many of us use, particularly on 10 gigahertz. They're the direct TV, or mine came from the neighbors across the street. They had scrappy days in Bloomington, and he had it in his junk pile, and I ran across the street and pulled it out of his junk pile. And there are commercial antennas. Directive systems are some of the better antennas commercially, as well as Force 12. Equipment, there's a blend here too. Down East Microwave is probably one of the premier suppliers of transverters for the microwave bands. He supplies them both built as well as kit form. The DB6NT, I don't know if Electrocrafts are in kits anymore or not. I know once upon a time they used to be. But Electrocraft has a series of 6.2, 222, and 432 transverters. But I don't know if those are kits anymore. And of course, there's the commercial stuff. If you have an FT817 or an 897, FT100, all those rigs, that typically will have 6.2, 432 in them, and you're there. You got something to start playing with.
Question about the TV antennas,
Yeah.
the dishes. Aren't they all like one-dimensional? They're not a true dish. They're either this way or that way. They're horizon in one dimension, so that.
So are you talking about the dish that you see, like a dish antenna?
TV and that, they seem to me to be all.
So that's what's called an offset dish versus a true parabolic. So a true parabolic will have the feed in the middle. They'll be they'll look like that with the feed in the middle. The offset dishes that you see, like Dish TV, are called offset, and they're half of a parabolic.
Yeah.
So that they're half a parabolic. And the advantage with them is that the feed doesn't block the dish. So if you've got a dish like this and the feed in the middle, you know, if it's aiming this way, the radio waves as they come in, the feed actually blocks a little bit of the signal coming in. And also, one of the advantages of the offset is you can, when you tilt them up for satellite work, is that they don't see the ground. The feed point looks away from the ground. The ground, because it's got a higher temperature, is noisy at those frequencies. And so that's why they use those offset dishes. So it's not, they're just like a parabolic, only it's half a parabolic. And again, they'll have, you know, on 10 gigs, they'll have about 30 dB a gain for a 19-inch dish. And that gives you about 3 degrees, both in azimuth and elevation. You know, it's kind of a circular, so you got to aim both ways.
Okay.
This is an example of something that I pieced together for the January VHF contest. I was, it was Friday and before the contest, and I saw it was supposed to snow during the contest, and Gary up in the north side of town has 5 and 10 on his dish. We're about 18 miles, 15 miles apart or so. And so I took my 5.7 system and mounted it on this little arm, and then this is another 10 gigahertz transverter I have. This runs about 2 or 3 watts, and this is a 17 dB horn that's plugged into. I just put it on an arm, and then this is the 2-meter rig. I've got my glove sitting up here because I didn't want the snow getting into it. So that's just a glove sitting there. But that's the 2-meter IF rig. And then I had a little coax switch where I could switch between either this transverter or this transverter. And it was snowing, and so I was able to contact Gary on 2 meters, and then we coordinated and we made a contact on 5 and 10 gigahertz snow scatter. So another contact, another point for the contest. But you know, just an example of some of the things you can kind of throw together and have some fun with. You know, because this group is technical, I also wanted to talk about light. Light contacts are something that we have talked about a lot, and you know, in my world where we're talking about stuff, but we haven't done a lot of work in yet. So we've talked a lot about it, but we haven't done anything about it. Light is really kind of interesting because in the old days when you talk about light, people usually talk about lasers, and lasers have all sorts of kind of problems associated with them in terms of safety, unless you're talking really low power lasers. What we have found through the years, we meaning as an amateur radio community, is that LEDs, and particularly like the Luxor, the higher power LEDs these days, actually provide better communications at distance than lasers do. So lasers have been dying off, and the LED stuff has been coming on. And so this is a picture off a website. It's a VK guy. I think they were making, what's it say there? It's a 104-mile optical contact using light. And they use these Fresnel lenses. So one of you can see it kind of red there. That's the transmit side. This is probably the receive side. And you know, making 104-mile contact using light is pretty cool. And then, yeah, and then the circuits, you know, this is a receiver down here. So, you know, as a club building things, this might be a project for you to put the bug in your ear. So, you know, try someday down the road is making some light contacts. As the circuits are fairly straightforward, fairly easy. I think this is just a 102 JFET here, and, you know, this is the detector diode. This is where the magic kind of happens, and then there's some amplification in here to get you up to where you can actually hear something. Pretty simple, pretty straightforward.
What color are the
They're infrared. So I forget the wavelength, 680 or something like that, 640. Someone know.
but not visible?
You can kind of see that reddish color. So they're at the far end of the red
Yeah.
scale. So you can see them, but they're much brighter than what they appear because the human eye doesn't respond real well to it. But it's red. So if you chase paperwork, there's all sorts of paperwork that you can do when you're operating VHF, UHF. You know, just like on HF, there's the DXCC for working DX. Here we have the VHF, UHF Century Club. So if everyone know what a grid is? Everyone familiar with grids? Grid's the main grid system that kind of divides the world up into these grids, and we use grids, we exchange grids. We're in EN 34 here, 35, close to 35. I think we're in 34, on the north end of EN 34. So if I was working on someone on 6 meters and they're down in Texas, they might give me Echo Mike 28, and I tell them we're in EN 34. And people collect these just like you collect countries. And if you work 100 grids on 6 meters or 100 grids on 2 meters, you get a certificate, and you can start adding additional stickers to it for every 25 grids that you work above and beyond that. So a lot of people do a lot of grid hunting. Grid chase, this is a little old probably, but this is grid chase data off the ARRL website for various bands. So you can see K1 TOL over there in New England. He's worked 1,400 grids on 6 meters, which is really amazing, yeah.
What do you have?
Even on 2 meters, 650 is nothing to sneeze at.
Where are you at on the list?
Down, you have to keep scrolling. Back in the day, I used to chase grids. I still record them, but I don't really chase them anymore. Working grids on 6 meters is really easy. I chase grids on the microwaves now. It's kind of like, if you're in HF long enough, everyone gravitates eventually to 160 meters or something like that. That's kind of same with the VHF stuff. I've gravitated to the microwave bands. I have probably around 250 or so on 6 meters. I have VUCC on all bands, essentially. Satellites. I couldn't pass up talking about satellites briefly. I have just played ever so briefly with satellites myself, but this is another aspect of the world above 50 megs that you can have a lot of fun with, is satellite work. This is a whole other spectrum, a whole other discussion maybe someone can give if you guys haven't talked about satellites in the past, but there's all sorts of things to talk about in terms of antennas. You can build your own antennas, tracking systems, how do you track the satellites, different kinds of orbits, uplink, downlink frequencies. I know a lot of the newer satellites I think are looking at microwave or are already using microwave links for up and down. There's different kinds of transponders. There's the linear transponders where it's like sideband up, sideband down, or CW up, CW down. There's FM. I remember a long time ago, the Russians had one of the early satellites that was a robot. You could send your call to the robot, and it would send your call back and say 73s or something like that. But you had to have the code space just right and stuff. And I remember doing that, and I think that was a lot of fun. But they're quite more sophisticated now. So, whole other area of the world above 50 megahertz is satellites and playing around with satellites. It's an area that I intend to get into, maybe when I retire, but at this time, I'm not. The digital modes, we talked about digital. So WSJT stands for Weak Signal Joe Taylor, WSJT. And it's a program that was written by K1JT, Joe Taylor. Joe's a really unique guy. I've had an opportunity to talk with him several times over the years. He is a Nobel laureate at Princeton, and he won the Nobel for his work in theory in detection of, quasars, I think it was. And just a real down-to-earth guy. He made a presentation at a conference I was at once. He brought his Nobel thing with him, his award, the big heavy thing. And he passed it around, so we were all able to kind of hold it and stuff, and that was really cool. He said, just one thing, I want it back at the end. Okay? So everyone just kind of, as it was passing around. That was cool. So Joe has this program. So one of the things about WSJT is that it's a software program. It loads, on your computer. It uses your sound card, and it receives audio from your radio. And because it uses digital signal processing, it has the ability to detect signals that are below the threshold of what you can hear with your ears. So it can add another 18 or so dB of improvement. Remember when we were looking at that one chart with the path loss? You can pick up another 18 to 20 dB roughly of improvement without having to add more power, more antennas, that kind of stuff. So what this does is the WSJT programs will now allow you to do things like moon bounce or even meteor scatter with much less stations, and we'll show that here in a second. There's kind of a suite of different kinds of digital modes. There's the FSK 441, the JT65, the Whisper. There's a whole bunch of them now. I think they're proliferating. You guys probably know more about it than I do, but the digital area is yet another aspect, not only in HF to some extent, but particularly in the VHF side that's just blown up and going all sorts of crazy ways. This is an example, a screenshot from the program. This is running FSK 441, which is used for meteor scatter, one of the ones used for meteor scatter. And basically the way it works is, this is what they use on 6 and 2 and also the other bands, but primarily 6 and 2. Running 100 watts and small antennas, you can make reliable contacts out to 1,000, 1,200 kilometers. It's again using meteor scatter, so it's usually early morning is best. Early morning is best because as the Earth is moving around its orbit, and it's also rotating, so you get day and night, as the morning side comes around, as it's moving like that, it's that morning side that kind of sweeps the space, if you will. And that's why meteor scatter is usually better in the early morning, starting at like 6 in the morning, 5 in the morning, until noon or so, and then it usually kind of dies off in the later afternoon hours. Although during a meteor shower you can get meteors then too. You can get meteors at any time. But generally speaking, it's those early morning hours that the meteor, the ping jockeys we call them, are making contacts. And this is the tool that they use. And there's a sequence that goes on. You can read about this if you download the program. But basically, there's a series of contacts here, or exchanges. And there's a little tick mark there. And so you'll set up a contact, or you can make random too. But if you set up a contact, and you'll start out sending. In this case, he's sending W8WN K1JT. And that's what he sends for a minute, and then he listens for a minute, and then you send for a minute, and then you listen for a minute. And suddenly, bing, there's a meteor, there's a detection, and there's a decode, and that message will come across, and then you move on to the next sequence. And so you kind of ratchet through these sequence of expected exchanges of information, calls, your location, or a signal report, depending upon what it is. And at the end, you're down here with 73s, and you've made your contact. So. Again, a lot of people playing with this. Take a look at Ping Jockey. So Chris, N0UK, who's local here, runs a net, a web site called Ping Jockey. So just Google Ping Jockey and you'll come up with that site. And that's where you get a lot of information about how to set up schedules and how to run meteor scatter as well. Same kind of program they use on EME. They use a slightly different mode. So the idea with the ping jockey is you're trying to send, or with meteors, is because the meteor trails only last for a brief period of time. So you're sending repeated data over and over again in a rapid way, waiting for that ping to come through, and when you get that ping, all the data gets through, okay? In comparison to EME, the moon is always there, so what you're trying to do is build redundant data so that it can put the message together based upon redundancy. So you're sending the same data, but it's in a different way. That's why it's a different kind of program. In this case, what's this one called? This one is JT6, I think. This is what they use again on 432. 100 watts or more, single Yeagis. I got an example to show you coming up. Same kind of like concept. You know, you work down through your list of predetermined exchanges based upon what you're seeing on the decodes. And as you get a decode up here, you'll see the information start to appear here, or nothing if you're not receiving anything.
On the meteor scatter, does it depend on several meteors to get through?
Yes.
Contact?
Yes. Yes. So here's an example of some EME arrays. Of course, this one on the bottom left is what used to be called the mighty array. It's a W5UN. He had 32 antennas, and this is this tower here with pivot, and this is an old Ford truck bed. And he had a tracker on the outside, so this thing would turn this way, and then you can turn it this way. And of course, he had a tremendous signal off the moon. One of the things that, you know, when you're working a guy like this, you need even a smaller and smaller antenna. There's been examples where I think he's worked guys, you know, working like a 4-element Yagi, you know, on 2 meters and 100 watts. So, you know, you just have to overcome that path loss. Again, going back to that chart that I had shown, you know, and however you come over that path loss, if he's doing all the heavy lifting, you know, path loss is path loss. So in this case, he's doing a lot of heavy lifting here. On the other end of the spectrum, this is Bill, K0AWU up in Grand Rapids, and that's his single Yagi. He just has a temporary setup. He's got a rotator right there, and then for elevation, he goes out about every 10 minutes and changes the elevation. And it's just a single long boom. I think it's a 24-foot or 26-foot boom on 2 meters, and that's what he uses for EME. Digital. Okay. Briefly wanted to talk about other things you can do. This is, again, kind of chasing paperwork. You know, everyone touts, you know, DXCC and 5-band DXCC and working CQ worldwide 40 zones, and those are all challenges and significant. This one's probably even more challenging and significant, and it's called the Fred Fish Memorial Award, and the idea is to make a contact on 6 meters with all 488 grids that make that touch the continental U.S. And so far, there's only been 5 people who have done it, who are listed there on the bottom left. So there's only 5 Fred Fish Awards right now. This color code kind of shows the rarity of the grids, if you will. And as you would expect, when you get out into the kind of more sparse areas of the country, it's a little bit harder. So one of the fun things to do, you can even see, so here we are in Minnesota, EN34, EN35 is just toward the north. But, sometimes, especially during June, July, when the sporadic E is going great guns, it's fun to go out and, put on a rare grid on 6 meters. Sometimes these guys go down and they'll put on rare grids. This one down here I wanted to show you just briefly. That's a rare one. It's down along the Rio Grande and the Texas border. So I'll circle that one. So it's DL88. Okay, so in grid squares, we usually go with the 4 digits, DL88. Okay, in this case, this is the next descriptor down, JX. So when you use these last digits here, that will take a 4-digit grid and divide it into 100 subgrids, and that's the subgrid designator. So this provides you greater resolution as to where you're at. Again, kind of like latitude, longitude. This is referred to as a 6-digit Maidenhead location. And that's, DL88. So just north of here is DL89. So this is, that's the Rio Grande, by the way. I'm sorry, I forgot to say that's Texas up here, and this is Mexico down here. So you can see it just barely touches, right? So you can see why it's rare, right? So when you get there, that's what you see. So, you can understand why there's not too many ham radio operators, let alone 6-meter ham radio operators. And so when people go on these, they call them grid D expeditions, they get announced out, and all the people who are chasing the Fred Fish Award get all excited, and they try to work on them, often using meteor scatter. So contests is another thing. My roots, again, HF contesting, so I do VHF contesting as well. Here's kind of a list. Summertime is pretty active. The big contests in the summertime are the June contest, CQ Worldwide, which, by the way, is only 6 and 2. And then in the fall, September is often a real big contest, that one. There are EME contests, all sorts of contests that go on. So there's always activity going on in the world above 50 megahertz. It's, whatever you want to make of it. If you want to get in there and be hardcore, or if you just want to get in there and have some fun, have at it.
Well, that's what I was going to say. What kind of activity would a little pistol see in a contest like this? Somebody that's, I just have a very basic setup on VHF.
So if you're on during a big contest, like the June contest, say, if you have 6 and 2 meters capability, so it will vary. There's a large, a large variation because VHF propagation is quite different from HF propagation. If it's a bad contest and there's no propagation, you'll work only locals for the most part, unless you do some meteor scatter. And you'll work, 50 contacts on 6 and maybe 30 contacts on 2 with a small station over the weekend. If it's a wild, crazy ass, excuse the language, 6-meter E-opening, which we've had sometimes during contests, you can work, 700, 800, 900 contacts on 6 meters. There's been some guys in the last couple of years who have cracked 1,000 Qs on 6 meters during the June contest. But that's not, so I always hate to paint it that way because it's kind of like fishing, Sometimes you go out and it's just crazy and they're just hitting all the time. Other times you go out and you just drown in minnows. You might as well stay home and read a book or something. That's kind of how VHF is. So a lot of contests, a lot of activities going on. Here's some other fun things that we did, just to kind of share with you other, fun things we're doing in the world above. We're fairly active as a club, the Northern Lights Radio Society, with the ARRL 10 gigahertz contest. There's actually 2 weekends that occur. There's a weekend in September and another one in August, as I recall. And a couple of years ago, we went up and we played across Lake Superior. So a couple of guys drove all the way over to Wawa, which is in Canada up here. And then we had some guys who were traveling up and down the French Riviera here, the North Shore, Norwegian Riviera, and making some contact with them. And our longest contacts across the lake was about 303 miles. We have noted in the past that if you get certain kinds of weather conditions, the propagation across the lake is phenomenal. And that's because when you get the right kind of conditions, the water wet, hate to say that, but it generates this a lot of moisture in the lower atmosphere, and as you go up, it will be dry and warm, and that kind of phenomenon creates this refraction that I was referring to. It's like tropal scatter, okay, tropal refraction in a more of a micro environment. But you remember at 10 gigahertz, a wavelength is only 3 centimeters, and so when you get these kind of sharp environmental / weather changes over a relatively small change in height going up in the atmosphere, you can really get some referred to as ducting. And so now radio signals, particularly microwave radio signals, will propagate large distances with almost no attenuation. So for instance, on some, not in this particular contest, these were actually kind of weak signals, but in previous contests we've made contacts going across the lake with just those little horn antennas, just a little horn antenna, and signals were like 20 over S9 over a couple hundred miles, just because there's no loss going over the water. That was fun. Here's an example of the Northern Lights group. We're on top of Buck Hill. This was a couple contests ago, the 10 gig contest. You can see all the 10 gig guys. And you know, for 10 gig contests, one of the things we often do is we'll have a group on Buck Hill, and then we have another group we send out as rovers, and they'll travel out to western Minnesota up onto the Buffalo Ridge, and then to South Dakota, or maybe down into northwest Iowa, and we'll make contacts doing that. So you can see all the dishes lined up. This is my dish right here. I'm going to show you a picture here in a minute of more of the feed area down here. But this is a 22-inch dish, and then the feed arm down here, and then my 2-meter rig here. So the transverter sits out here. The 10 gig signals hit the dish, they're reflected into the feed horn right there, and then the transverter sits right here that takes 10 gigahertz and converts it to 2 meters, and that's what I receive on and transmit on is 2 meters. This is a DB6NT transverter that I built as a kit many years ago. But you can see kind of similar systems. We call this guy here Big Dish Dave. That's Dave N0KP. He's always using the biggest dish. Yeah, but you can see, you know, here's a Sony dish and a lot of similar systems going down the line. So here's a close-up of my dish. Again, kind of construction-wise, you can see the arm coming out here, okay? One of the things with 10 gigahertz is, you know, because it's such a high frequency, you do have high losses, so you try to keep the receiver, if you will, the transverter, as close to the feed horn as possible. So again, here's that feed horn. This is a home-built feed horn, and that feed horn is designed to have a particular gain for that dish, because you want to illuminate the dish just in the right way. You don't want to under-illuminate it, and you don't want to over-illuminate it. So that particular design is unique for this dish. And that, if you look into here, which you should never do, but if you look into here, this is a transition. There's a coax, there's a little pin that sticks in here. And so it takes the 10 gig energy and it converts it to coax. And this is coax that goes in. And there's a SMA relay right here that goes between transmit and receive. So the receive goes into the transfer, the transmit goes into an amplifier. I run about 8 watts on 10 gigahertz, and that's a little amplifier with a heat sink on top of it. So an example of some of the things that we build on 10 gig in other microwave bands. Here's some paperwork that you can get. So, you know, if you're into chasing paperwork, just like on HF, you know, whether you're doing county hunting, contests, whatever, we have paperwork too. I had to work on that for a while too. Another thing I like doing is roving. So sometimes I like to throw all the stuff in my car and go out, particularly during these contests, because when you go into a grid, remember those Maidenhead grids? Every time I'm in a new grid, I can work people again. And people really like me because I go to these really rare grids where there's no one, particularly on these other bands. And so you're very attractive to other people and they look for you. So here is my little setup, it's my older car. But this little rack system, I think there's a picture coming up, was built by Big Dish Dave. He put that together for me. And then the various antennas, I'll show you in a second. And my 10 gig, my 5 gig system. I think I'm down here, this is down east of Rochester, St. Charles area, where the 4 grids come together down there. I'm looking back towards the Twin Cities. One of the nice things about roving is you get out, you know? I mean, you know, that earlier picture I showed you and stuff, and this picture, I mean, it's gorgeous out. It's kind of like road rally / touring / plant radio. So here's an example of some of the antennas on that rack. This is a 4-element 2-meter, and then it's also a 4-element 222. I modified it, so this is kind of a semi-homebrew antenna for 2 and 222. 902, excuse me, we're 432. So here's 432 down here. And you notice these are, you know, they're 4 or 5 foot booms, so they're not big antennas. So they're not very big antennas, but they work very well. 902, Loop Yagi, 1296, Loop Yagi, 2304 sits on the top, 3456. And then for 6 meters, this particular time, that's a 6-meter hamstick. And if you notice, one of the things I figured out is that this 3456 looper is just about the same length as that one. So this is actually a kind of a 6-meter dipole. You know, and it works pretty good for what it is. You know, it's a dipole at 8 feet. Here's the inside of the car. I don't think I have a picture of the back, but what I do here is, so this is an FT897 that runs 6 to 432 stock. I've modified it for also 222. So these are my lower 4 bands right here. For 222, what I did is, I don't know if those who are familiar with an 897, but there's a battery compartment in here. It's a big space on the top. And a friend of mine brought one of these to the Northern Lights meeting one day, I said, wow, that's a big space in there. I wonder if a transverter would fit in there. So I did a quick measurement, and lo and behold, I found out that the down east transverter boards would drop inside there. So I modified mine so that little switch on top that's normally the battery, AV battery connection, turns on and off my 222 transverter for 10 meters. So it's either 10 meters or 222. So that feeds into my stack of 100-watt bricks for, it will run 100 watts on 6, okay? And then I've got 100 watts on 222, 2 meters and 432. So that's the lower bands. And then for the higher bands, this is what we refer to as the IF rig. So it's actually a 2 meter, it's a TR751A, something like that. It's an old 2 meter rig, single band. And it goes into the coax switch here. And this is a 4-position coax switch. And then I have 4 coaxes, and you can't see in the back seat are all my transverters for 902, 1296, 2304, 3456. And I have it set up so when you do the PTT, it puts the DC onto the coax, and it will switch the transverter, so I have no PTT lines. All I have to do is take that coax switch and just go click, 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 and I switch from 902 to 1296 to 2304 to 3456. So, nice clean setup, not real messy, not a lot of cables. And then I've got the power thing on top here where I can quickly unplug things when the flames appear. And then just a couple more slides here. This is, I just want to show you, there's a question about what's going on locally. For weak signal VHF activity, it's the Northern Lights Radio Society. I'm currently the president of Northern Lights. We have anywhere between 60 to about 80 members. We have breakfasts that we alternate at Old Country Buffet. Second, in fact, it's next weekend coming up. And everyone's invited, club members, whatever. If you're interested in VHF, stop by. We also put on a conference in the spring called Aurora. We have an antenna range in the morning, and then in the afternoon we have a technical conference. It's a great place to meet and hobnob with people. This is the website. If you go to nlrs.org, you'll find out all this information. Excuse me, that's what the website looks like. So if this is something that interests you, that might be something you might want to follow up on. Also, Central States VHF Society is active in the upper Midwest. The Central States has been around for 50 years or so now. It has maybe a couple hundred members, obviously mostly over the Central States area. We have a conference every summer in late July. Usually attracts about 110, 120 people. It's kind of a 2-day conference. This year it will be in Denver, and next year it will be here in Minneapolis. And so this is something to, again, just do csvhf.org, and you'll get to this website. So, and again, the conferences, they'll have antenna ranges, they have a flea market, they have an antenna building 101 session, and then we have a technical presentation as well as a banquet on Saturday night. So it's a lot of fun. It's a great place to learn about stuff. They are like this group on steroids to some extent, okay? And so that loops us back around. So these are the questions. So we talked about what can be done on VHF, UHF, and microwave. We talked about kind of what you can work, what it takes. I think the important part there is that, particularly on VHF, UHF, you probably have the capability already on your radio, especially 6 meters. Technical hurdles are nothing you guys can't handle, and that just as you guys know, the way you learn is you jump in. It's not like you have to go to school for 4 years before you can hit the 50 button. Just jump in and start learning. Moon bounce is very capable. If you have 100 watts and a long boom Yagi on 2, you're there. You can do digital, and you can make improvements after that. What's it take to get started? We kind of talked about. Equipment I've built, I have a blend of commercial as well as homebrew stuff. You saw my FT897 that I've modified. Some of the transverters I've bought commercially. Some of them I've built as kits. Some of them are semi-custom where, they're commercial, but then I've added an amplifier to them to myself. So, there's a blend of things that you can do there. And then, locally, the Northern Lights is the group that is active on these bands and doing these kinds of things. And I gave you the website. And I think that's what I have. So any questions, any comments? Yeah.
If anybody wants DSS dishes, I have seveal. For you, whoever wants them.
It's a great price. So what we do on those DSS dishes, and you can read about this online too, do they have feeds?
All the parts are there that was used for DSS, yeah.
The LNA's there?
Yes.
Okay. So the LNA typically on those will not work on 10 gigs because they're just a little bit below that. But what can be done is you basically take the LNA. I think you guys have seen that. It's, they look like a kind of a big pack of cigarettes with a knob on it. That knob is the feed part. You can open up the back of it and you basically rip out the electronics because you don't need that. You just want the feed. And then you can take a drill and you can you have to chuck it up. So if you have that mechanical capability, that's great. If not, there's NLRS club members who do. And you have to just expand the throat a little bit. It's ever so slight. I forget the exact dimensions. And once you do that, then you can just put a little SMA probe in the side, and then you've got your feed. The advantage of that is that it's all mechanically set up. One of the problems with an offset dish is trying to figure out where the feed point is. Because in a parabolic dish, it's symmetrical. It's in the middle, And you got this dish, it's like, okay, where the heck is the feed point in there, And there's actually ways to do that, and there's some discussions on the internet about, you measure the dimensions, and then you can measure out this way, and that's where the feed goes. But if you use a commercial one like a Direct TV, it's already set up. You don't have to worry about it. So that's an advantage of going that route. Any other questions? Yeah.
There seems to be a current interest in using things like Raspberry Pi and the ham privileges in the Wi-Fi bands with this thing called the ham mesh net, and kind of an ad hoc network you drive. If you have the equipment, you drive to a certain area and you can set up a full Wi-Fi capability in the ham bands.
Right.
You familiar with any of that? Or
Just briefly, yeah. There are guys who, because the 2304 band overlaps with Wi-Fi, there's certain channels, I forget exactly the descriptors from, but some of the pardon?
1 to 6.
1 to 6, is that the full? And there's a couple of those channels that overlap the ham band.
Yeah.
Is it the higher bands or the lower ones? I don't remember. But anyway, the point is that there's, you can take commercially available Wi-Fi equipment and under an amateur radio license modify it to do certain things and then play in the ham band aspect using that, Wi-Fi equipment for, I've seen guys doing it for, like ATV or television fest. I don't know the TV stuff as well, but doing television stuff, doing links for parades and public service stuff. And so yes, there's that the whole Wi-Fi crowd out there. There's kind of, no pun intended, a spectrum of Wi-Fi guys, all the way from non-ham hackers who are trying to use Pringle cans for gain antennas, which doesn't work by the way, to very technical people who know their stuff and are doing some really technical stuff. There's a lot of stuff going on in the 2.3 band.
Yeah, they've actually brought it down to 900 megahertz now.
Okay.
So there's a whole activity there as well as in C-band around 5.
Okay.
It's actually quite active in town here.
Okay.
And I think Aries has got a splinter group looking into it right now.
Oh, interesting. Okay. Yeah.
I look at some of the Down East microwave and some of the transfers you can buy, and of course, Kenwood's offerings are really low, minimal for microwave bands, but some of that equipment's pretty expensive. Do you have any leads on, I don't know, mill surplus eBay things to look for to get on like upper bands, microwaves, and
yeah, unfortunately, it's gotten more expensive. Through the years, we've gone from having a lot of surplus equipment and a lot of lower cost equipment to the radio surplus places basically are going out of business, and the surplus stuff is drying up and going away, and that makes it harder and harder. There are some guys who do put together the stuff, and there's some information on the internet if you maybe Google like homebrew microwave station or something like that. It's unfortunate prices have gone up. When I bought my DV6NT for 10 gigs, I think I paid $180 in kit for them, and that was before the dollar and the euro thing went on. So that's how long ago it was. I think now so their kits. Do you remember how much like the kits were? Was it $400, something in that range?
Yeah, 4, 6
Yeah,
per band.
yeah. 4 was 4. I think it was 4, and then 6 if you buy them pre-made. So unfortunately, it's gotten more expensive. It's unfortunate. There are still opportunities for home brewing in that environment.
seen like, what are they, gig oscillators on
Yeah,
eBay? And
yes, there are, yep, and so there are, you know, Northern Lights guys who are a little bit more familiar with that, you know, a little bit deeper technology aspect of it.
that's,
Yeah,
for
yeah,
those, the Russian triodes,
yeah, yeah. You know, basically, you know, to get to the microwaves, you need, you know, an antenna and then potentially a front end of some kind, you know, an RF amplifier and then a mixer, and then you need something that feeds a local oscillator that feeds that mixer, and then the output from that can go into your 2-meter rig or something. So there are guys who, you know, look for certain kinds of brick oscillators that are military surplus or commercial surplus that might work well, and put some things together there. But yeah, there are guys who are doing that, but it's not cut and dry. It's very much you know, full custom. You know, it's when you find something out there, you find one. You know, and then so you do something around it, but you know, no one can replicate it because they found the only, you know, LO that works. So, and from that perspective, it's kind of unique and a technical challenge, in that you kind of have to, you know, have some knowledge around how to do that and what to look for. So, any other questions?
Are there whole group type places you go to find plans for ideas to build this kind of stuff, or what's the collection point for that?
What's the collection point for that? Good question. I don't have a quick answer for you.
Okay.
You know, nothing leaps out at me. Obviously, you know, there's a lot of, so these conferences like the Central States Conference, there's a lot of presentations that go on, and there's a proceedings that's published. So if you go to the ARRL website and look for the proceedings, like recent one in the East Coast was the microwave update. They call it MUD, microwave update. Our Central States VHF, there's a history of proceedings, and often those presentations deal with all sorts of things from propagation to construction things. Like I said, one of the more recent things that have been going on as far as construction goes that have been around the solid-state amplifiers, because again, in the older days, you know, the way to get to high power on the high bands was through tubes. But in the last couple of years, there's been a lot of the solid-state designs for very low cost, considering, you know, we're talking like $100, $150 for the kit aspects of it, which a lot of people have been putting together and doing. And there's been some articles on that. So if you
how about your club now? Do you have a lot of exchange of ideas how to build things and everything there at your club meetings, or
we do
mostly operating?
We do. It's a full spectrum club in terms of all the kind of. So we talk about operating, we talk about construction, we talk about antennas. So it's just not limited just to construction. And we have a wide range of people with experience. Some are just 6-meter ops. Some are just doing microwaves. So it's a whole spectrum. Yeah. So it's a good group of guys and gals. You know, the only thing I can say is the internet is really powerful these days. You know, you can try Googling on different subjects like, you know, homebrew, VHF transverter, et cetera, and you'll get all sorts of different hits. A lot of these guys publish a lot on the internet. There's a lot of articles out there, a lot of articles. But it's a lot of fun. Like I said, it's something I've been doing for a long time. And whether I'm operating from home or, you know, out roving and stuff, it's just a lot of fun. Any other questions? So everyone going to get on 6 meters now? You know what that 50 button is? You know, the cool thing about 6 meters is when the band's open, it doesn't take much of an antenna either. You know, you can put up a dipole or a loop. And you can load up your 80-meter dipole. Yeah, that's one of the things that I often encourage people if they don't have a 6-meter antenna, is just try your different antennas you have up and see if it loads. You know, if it's under 2 to 1, bingo, bango, you're on.
And I think a 6-meter dipole is a little over 10 feet. So I think you need 2 sticks of copper pipe, and you have yourself a rotatable dipole.
Right. Yep.
And that, I mean, even when the band is in what I'd say average shape, I can work KMZRT down in Sioux City.
Yep. Yeah, it's a lot of fun. I think I've said that 4 or 5 times. But you know, so 6 meters, 2 meters. The other thing is, you know, during the June contest, roving, you know, because the exchange are these grid squares. Everyone likes grid squares, so often rovers go to a grid corner. There's 2 grid corners that are nearby here. One is just west of town, out by Buffalo. Excuse me. That's where EN 24, 25, 34, 35 come together. And you can just move a very short distance and work those 4 grids. So, you know, if you put together a homebrew 6-meter antenna and take your 2-meter J-pole out there, you can have a lot of fun, particularly like in the June contest. Okay? Thank you, everybody.
Thanks, John. Appreciate you taking the time to come.
Yeah, thanks for inviting me.
Perfect, and any more questions, you know, John, you're available.